the second portion of today is finding the power of a power, which derives from the multiplication laws or rules. So if I look at this example, 4 to the third all to the second power. Well, if I ever have anything to the second power, that means I multiply it by itself. So I'm going to take 4 to the third times 4 to the third. But since we know that, and we just learned that if we have the same base and we're multiplying, I can add my two exponents together. So this is really 4 to the sixth power. So the shortcut here, when you have a power to a power, is to multiply those two things together. So this is our power to a power rule. If you have a power to a power, you can multiply those two powers together and keep the same base. Alright, so let's use this in a couple scenarios here quickly. So 7 to the fourth, all to the third. Since we're taking a power to a power, I just multiply those two together and I have 7 to the 12th power. Alright, looking at B. 3 to the sixth power, all to the 0 power. And since everything to the 0 power comes out to 1, and this will confirm this, if I take 6 times 0 anyway, I get 3 to the 0 power, which equals 1. But if anything is all to the 0 power, you can just skip right there. It will always be 1. Alright, let's check out letter C. We have x to the second all to the negative 4. So here's what I would do. I would take 2 times negative 4, and we get x to the negative 8th times x to the 5th. And now that I have the same base here, I can add negative 8 and 5 together using that multiplication rule with the same bases. X to the negative third, which equals 1 over x to the positive third. And there we go, that is simplified. Alright, a couple more examples here, and this will be it. Letter A, here's where we got to be a little bit careful. When we've got two things going on the inside, remember that negative 3 is to its own power here, is to the first. So here's how I would write this out. Technically, this means negative 3x times negative 3x, which if we do some reordering and I do negative 3 times negative 3, I get positive 9, and x times x is x to the second. So this is what we should get, and the shortcut is where you have to be a little bit careful, because if I'm squaring now negative 3 to the first power, that's negative 3 times negative 3, which is my 9, and then x to the first to the second would be 2 times 1, which is where I get this from. Notice that in letter B we're going to get the same exact answer, except for, so we would square 3 and get 9 to the second, or sorry, 9, and then x to the second. So I would take 2 times 1 there. But this will be negative because this square does not apply to that negative. It's not included in those parentheses. Lastly here, a couple different ways to go about this one. But this is almost like a distributive property, kind of. So I would do power to a power, 3 times 0, which is going to be y to the 0, and 3 times negative 2, which is negative 6. Well, y to the 0 is just 1, and x to the negative 6 is 1 over x to the positive 6. And there we go. Alright, so that is the second law or rule here for power to a power.